The length L of a simple pendulum varies directly as the square of its period. If a pendulum with period 4 seconds is 64 centimeter long, find the length of a pendulum whose period is 9 seconds. So this is very similar to the previous problem I solved earlier on. This is a variation problem. Now what the question says, it says the length of a pendulum. So the length has been denoted by L, or is denoted with L. The length of a simple pendulum varies directly as the square of its period. So anytime you see problems like this, the first thing is you should try to decipher the relationship between the two items of the problem statement. So what I have here is L. So it says L varies directly. So it varies directly as the square of its period. So since it's a direct variation, it has to be t. But it says as the square of the period, as the square of t. So it varies directly as t squared. So this is how to decipher the statements here. Now again, the way it's being written, it's not useful to work with this. So I need to convert this to an equation. This is just a proportionality expression here. So what I have here is L proportional to t squared, so which is the same thing as L equals, so anytime you change the proportionality sign to equality sign, you should always attach the constant of proportionality to it here. So it multiplies whatever you have on the right hand side. So it multiplies t squared. So this is just L equals kt squared. So this equation that you have here models the behavior between L and t. Now let's go ahead and read the rest of the problem statement here. So it says if a pendulum with period 4 seconds is 64 centimeter long. So that says period, since our period is denoted with t, so this is t. So it says if t equals 4, then the length is 64. So let me just write that down. So we've been told that when t equals 4, the length is 64. So I can use this information here to find k. So let's substitute that here. So it says when L is 64, so when L is 64 here, you have 64 equals, so your k, you have k, and then t is 4, so you have 4 squared. So this is just going to be the same thing as 64 equals k times, now 4 squared is 16, so this is 16, so you have 64 equals 16 times k, that is 16k. Now to find k, I have to divide both sides by 16. So you divide by 16, divide by 16, so this goes off, and 16 in 64 is going to give you 4. So my k equals 4. So since my k equals 4, I can now rewrite this model as L equals, so you have 4 t squared. So this is the equation that properly models the behavior between L and t. Now what the question says, it says find the length, so find L when the period is 9 seconds. So let's write that down. So it says find, so this is the problem statement here. It says find L when t equals 9. So I'm going to be using this. So since I'm using this, so I want to find L. So we have L equals, it says 4 times t squared. So my t is 9. So 4 times 9 squared. 4 times 9 squared. And that's just going to give us, so you have L equals 4 times 9 squared is 81. That is 81. And 4 times 81 is 324 centimeter. So your length is so it says when the period is 9, so the length is going to be 324 centimeters. So that's the solution. So that's 324 centimeter here.